WarsawJS.
Hi there, I'm Mikołaj. I work here at Packhelp, and at Packhelp we produce hassle-free packaging for our clients. And what I do here at Packhelp, I take care of our online editor. Basically, what you do, you design the packaging online in the video editor. You hit the buy button, and in a couple of weeks, the packaging arrives. And there's one experience working here. I wanted to share that when you work on something that produces into something physical and real, it's a very interesting experience. And tonight I want to share another experience with you that also is quite magical for me. I want to tell you a story for Photon, about light and video. Oh, this editor, right? Now it works. All right, please participate with me. Imagine a sunny day, you're on the beach or in the park, and maybe even close your eyes and think about like the light, the trees, the grass, the water, and now think about the sun somewhere in space that sends light to Earth, that travels those waves and photons that travels to space. Then they reach you, your place, park, or a beach, and then they hit clouds, water, trees, grass, and they reflect, bounce back into your eyeballs, and this is how we see, right? This is magic that this light, those waves, they bounce back. And for example, you take out the phone and you want to record the video and send it to your friend. Then those light waves, those photons, they travel through the lens of your phone. Then they hit the image sensor. They hit the pixel in the image sensor. And those photons, they hit electrons that trigger a microvoltage, a measurable microvoltage that we can convert into ones and zeros and produce an image. And you repeat that process 30 times a second, you get a video, right? And there is something magical about this, that we can convert light, then store this dance of light as a file, then send it to our friend, then he takes out his phone or her phone, hits the play button, and the screen emits light in the same choreographical dance, and it was like the one you've captured. And I wanted to share you some ideas how this process works behind the curtains. And yeah, this is the journey I want to tell you about. So now a quiz time. Okay, quiz time. Who remembers files like that? All right. MP3s, VNAP, good old vibes. Great. So now, do you know any of those terms? Have you seen them? Have you on some labels? Raise your hands. All right. Some video experts here. More terms. All right. Do you think you know some of those terms, or have seen them, or have a faint idea? Right, fewer hands. All right, let's go further. Do you know any of those terms, you think? All right, good. So I want to shed you some light about some of those terms. So let's start with MP3. Do you know what MP3 stands for really? All right, one hand, two. Okay, what does it stand for? Yes, exactly. So MP3 is basically MPEG-3. And do we know what MPEG is? What MPEG means? And they even have a logo. Yes, exactly. So MPEG is an organization that basically creates standards. And if you think about it, they're less like engineers and programmers and more like lawyers who can create and draft standards. So this is their logo. It's one of the most organized body in the industry. So it's a moving pictures expert group. And so what I want to take you out, the video is just moving pictures. And one of the interesting things about that about video is that if we take this random wallpaper, full HD wallpaper, just downloaded from the internet, it's 340 kilobytes. And if you do the math, okay, clicker works. So at a frame rate of 30 images per second, 30 pictures per second, and that would amount to something around 10 megabytes of data per second. And for a 2-hour movie, that would be roughly 70 gigabytes. But the files we download, movies we download from the internet, legally from BitTorrent or something like that, are around 2 gigabytes. So this gives us something around 97 compression ratio, like pretty impressive. How do they do that? And interesting. All right. So I want to tell you what's an encoder and some of those terms. What's like encoding, decoding, H.264, many others like that. So encoding is basically compression. It's like encoding, compress, decode, decompress. So all those H.264s are compression algorithms. So how compression works? It's quite simple. For example, we have a string like AABB 15 bytes. You think out some format, how you can like compress it in a lossless way, and you have less strings. So you can just write a function that accepts strings, like simple stuff, compress and decompress. So the job of an encoder is to find a way how to maximally efficiently compress all those pictures. So if you imagine a video, it's picture, 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 picture. You take all those pictures, find out a way how to compress it in the most efficient way, and this is how you compress them. And basically, encoder sees your video like that. It chops the video and the pictures into areas. Then he tries to figure out the areas that move and that don't. Remember, moving pictures. But some parts of the pictures, the picture of a video, they don't move. And then they basically and basically you do this. They store the same pictures in a more efficient data format. So all the encoding, decoding is basically compression and decompression, and the real like compression ratio of like raw image data is 99.97%. If you really like decompress the file into like raw bitmap, it's gonna be terabytes per hour. So a part of this, all this video magic is things like encoding, H.264, H.265, HEVC, VP9, AV1, VP9, VP10, VP11 are just basically compression algorithms. So so you take out from this short presentation, the next time you see all those terms, you might at least know what MPEG stands for, what MP3 really means, what MP4 means, and what some of those terms mean. So this is really interesting how we can have something magical, like capturing light into device, and then create very special and unique ways how we can actually make this magic happen. This is all. Thank you.
Could you explain what's the difference between H264 and 65?
As far as I remember, like 264 is like a 2003 compression algorithm format, and 265 is in like newer version of it, because our computers and CPUs got much faster, and we can create more CPU intensive algorithms to compress and decompress video. So this is basically a newer version of algorithm that parses the file and applies different other optimizations that were not really possible like 20 years ago. Any more?
Thank you very much.